Okay, false alarm. I think I was saying pretty definitively that we were done with 6.5 in the last video, but I forgot about temperature conversions, which are, in fairness, fairly randomly just kind of inserted at the end of this section. We're going to look at two different units for temperature. Temperature is measured in degrees, either degrees Fahrenheit or Celsius. Technically, there's a third system, Kelvin. Degrees Kelvin. Kelvin is really just kind of a shifted version of Celsius, though. So we can kind of stick with Fahrenheit and Celsius, and that's pretty much good enough. What's interesting about these temperature conversions in these two systems is they don't agree on what temperature 0 degrees is. In a way that, like, for length or volume or mass or something, right? 0 pounds is the same thing as 0 kilograms, is the same thing as 0 tons, right? 0 inches is the same thing as 0 feet, is the same thing as 0 miles, is the same thing as 0 meters, and so on and so forth, right? But for Fahrenheit and Celsius, 0 degrees in Celsius, and so this is the temperature where water freezes, just for reference. So 0 degrees in Celsius is equal to 32 degrees in Fahrenheit. So there's a mismatch there. And in some sense, while that maybe shouldn't seem like such a big deal, it does affect the conversions and how we do them. It means it's not just a matter of having kind of a rate and you kind of multiply or divide. What you need to do is also kind of shift up or down to account for this, like a discrepancy in where the 0 lies. Before you kind of multiply or divide, you kind of need to do a shift to kind of set yourself at the same kind of point, and then you can sort of multiply or divide. For comparison, for another comparison point, the temperature where water boils in Celsius is 100 degrees. So you can kind of see where the Celsius system is coming from, right? It's essentially just, right, you're taking the difference between water freezing and water boiling, which is, right, you could imagine pretty useful temperatures to know, especially from a sort of a science, chemistry, physics kind of place. And you're just saying, okay, well, freezing is 0 and boiling is 100, and we're just going to divide up everything evenly from there. In Fahrenheit, water boils at 212 degrees Fahrenheit. So, right, it's not a 100 degrees shift in Fahrenheit. This is what, 180 degrees, right? It's a shift, it doesn't hit 0, it doesn't hit 100. I think Fahrenheit, the one thing I'll say about Fahrenheit is I think, 100 degrees in Fahrenheit is sort of around like human body temperature, right? 98.6 is kind of the classic, how warm is a human. And so 100 degrees Fahrenheit is around there. I'm not 100% if that's sort of where this came from. But just as a reference, I think, Fahrenheit is kind of like the American system is sort of coming from, what are common values type place versus the metric system, which is a little bit more organized. In any event, so what this means as far as excuse me, as far as doing these conversions, is we're going to have not just a rate, we're going to have, maybe something you would sort of think of as like a linear formula for converting. And this is really the same formula. I'm going to give you two versions of it, one to sort of go one way and one the other. It's really just the same formula, kind of forwards and backwards. But you'll see, I think, when we lay them out, kind of the difference between them. So version 1 would be degrees Fahrenheit is equal to 9/5 times degrees Celsius plus 32. So that's going to be used for conversions from Celsius into Fahrenheit, right? So the idea is you plug in whatever your degrees Celsius are here into the formula, multiply by 9 over 5, it's a little fraction work, and then add the 32, right? So that's version kind of 1. The second version would be sort of flipping this around and getting a formula that would convert you from Fahrenheit into Celsius. And so what that's going to look like is 5 over 9 times the quantity, degrees Fahrenheit minus 32. And so we're going to use that one for converting from Fahrenheit into Celsius. So you can see, these are very much kind of reversed versions of each other. There's an order of operations thing that's happening here, right? In the second one, you want to make sure you do this subtraction first in the parentheses and then multiply by 5 over 9, the reciprocal, right, of multiplying by 9/5 in the other one and adding. So you could imagine kind of setting these up and sort of, starting with this and sort of algebraically subtracting 32 and, dividing by 9/5 to kind of solve for Celsius. That would be kind of how it goes. We'll just run a couple quick examples here. So let's convert 25 degrees Celsius into degrees Fahrenheit. So I want to go Celsius to Fahrenheit, so we'll use this formula, right? So that's degrees Fahrenheit. So 9 over 5. So times degrees Celsius. So I'm just going to sub in my 25 there. Right? And that whole thing is plus 32. So this is really just an order of operations type problem at this point. We could think of this as, 9 over 5 kind of, right? 25 would be 25 over 1, right? So if we're thinking of sort of canceling and stuff, right? This is 25 is 5 times 5, right? So it'll be 5 over 1 times 9 over 1 and then plus 32. So that's going to be what, 45? Plus that 32, so this would be a nice, pleasant 77 degrees Fahrenheit. So 25 in Celsius is like a nice 77 degree temperature, right? That kind of upper 70s, maybe a little sunshine, not too sunny, just a nice day. If we run from the other direction, so if we start with degrees Celsius, let's convert, or no, sorry, what am I saying? We just did Celsius. Sorry, I was looking at the wrong spot in my notes. Let's convert 50 degrees Fahrenheit into degrees Celsius. So 50, right, November-ish, New England, later in the fall, not quite winter. If we were in the spring, maybe you hit, March, you hit a nice 50-degree day. People are probably walking around in t-shirts. So this is, in some sense, as always, everything is kind of relative. So we're going to use the second formula here, right? So to go from Fahrenheit into Celsius, we'll use the second version. So Celsius will be 5 over 9 times, so we'll sub in our 50 in the parentheses and then minus 32. And so the difference here, from an order of operations perspective, is we're going to do that subtraction first, right? So 50 minus 32, right? That's going to get us 18 here on the inside. We can even think of this as 18 over 1, because then we're going to multiply, right? A pretty quick cancellation here. 9 is going to go in there twice. So this is 5 times 2 would be 10 degrees in Celsius. And that's how it goes. That's how we do that. Pretty good. I would say, you can do this both for positive or negative temperatures. We didn't do any negative temperatures here, right? But, the whole idea is obviously you can get temperatures lower than water freezing, right? When it snows, for example, it has to be less than 32 degrees Fahrenheit, and that certainly can happen. This formula works for positives and negatives. You're going to use it just exactly the same way. So just something to be aware of. An interesting problem that you can sort of do for fun, if you're nerdy enough, is you can actually look for and find there's a temperature where Fahrenheit and Celsius overlap. They actually overlap and hit, where, you know, a certain degrees in Celsius is equal to the same temperature in Fahrenheit. So there is a point where they kind of cross and line up. I'll tell you that it's a negative temperature, so it is a negative value, but I'll kind of maybe leave that for you guys to explore on your own. So enjoy. That is the actual end of 6.5, and we'll have our time and our speed conversions coming up next in 6.6.